Good morning, everyone. So, this is the video lecture on machine learning data pre-processing techniques. So, in the last machine learning data pre-processing, we have gone with data cleaning, data integration, data transformation. In today's class, we are going to see what is data reduction. So, reduction is nothing but you are going to reduce the data. Okay. So, what is the meaning of data reduction? So it is the meaning is obtain the reduced representation of data set that is much smaller in volume but produces the same result. So reduce the data. So that reduce the data in volume. Volume means in terms of space. But then also you should produce the same analytical result. Okay. So what you're having the complete data, you are getting the output. So when you reduce the data also, you should get the same output. So that is the data reduction process. So why you are going for the data reduction? That means why you are going with a reducing concept. So that is a database. Why data reduction? A database or data warehouse may store terabytes of data. Okay, so it is not gigabytes, it is than upper than gigabytes, that is gigatera. So it may store terabytes of data. Okay, so complete data analysis may take a very long time to run on a complete data set if the data is not reduced. So okay, if the data is not reduced, so it is going to take very long time to run on a complete data set. That's why you have to go with a reducing the data, but then also you should get the same output what you were getting before reducing the data. Keep in your mind, so you reduce the data and you which takes very small time when you reduce, but what output you are expected without the reduction, the same thing you should get after reduction also. Okay, so now you come further, which are the data reduction techniques. So data reduction techniques are this one. So first one is dimensionality reduction. Second one, numerosity reduction. Third one, data compression. So come for the dimensionality reduction. Depending on the dimensions, so like what you can tell, this file is of this much dimensions. Okay, so you can remove unimportant attributes, remove unimportant attributes for using wavelet transforms. Next, you go with a principal component analysis. Next, feature creation and feature subset selection. So these are the some of the methods of dimensionality reduction. So that means you are going to remove unimportant attributes. Okay, so which are the forms? One is wavelet, second one is PCA, third one is subset selection and feature creation. Okay, so come for the next one. Next you have numerosity reduction. So numerosity means based on numbers of data, you are going to reduce. Suppose there is an attribute age. Age is an attribute of 100 values. Okay, then you can reduce that particular numbers. So reducing that particular numbers, we go with a regression. Next, histograms, class clustering and sampling. So finally you go with a data cube aggregation. These are the methods. Okay, so other one is data compression. So data compression means best example is WinZip or WinRAR. So WinZip or WinRAR are the examples where you compress the data. So that is the data compression. So next you come for the first one, feature creation. So we shall discuss each and everything. Okay. So under dimensionality reduction, you are considering future creation. So that future creation that we will see. Okay, so create futures, which futures are very important, so that you have to create. So create a new attributes that contribute the important information in the data set than the original ones. So there are 20 attributes. Okay, so from the 20 attributes, so some value or some output is derived. Okay, so C create a new attributes, so which can capture the important information. Out of 20 attributes, you take some 10 to 15 attributes. Okay, so that should create a new attribute. Okay, so three general methodologies are used. One is attribute extraction, mapping the data to new space, attribute construction. So these are the three forms you are taking. So future creation means which futures are very important. So that one you have to take it here. So which futures are very important here. So that one will be considered. Out of 20, if very important are 10 or 12, then consider that 10 or 12 attributes. So how you consider that using attribute extraction, mapping data to new space, and attribute construction. These are the three methods we use for the future construction. Okay, so next you come for the numerosity reduction. So come for this part here. So first under dimensionality, we have gone with a future creation. Now you are in numerosity reduction. That means depending on the values. So here you are removing the entire attribute set also. In dimensions, you are removing the unimportant attributes. But as in numerosity, you come for the values. So which values are very important, that you take it here. So reduce the data volume by choosing alternative smaller forms of representation. So examples are, there are two types of methods. One is parametric method, which takes regression. So the regression we have already discussed. It is a single linear and multilinear regression we are taking. So here we come with the values of the attributes. So reducing the values of the attributes. But in dimensionality, we remove the attribute only. So that is the concept here. So here we reduce the attribute, values of the attribute, whereas in dimensionality, we reduce the attribute itself. Okay, remove an attribute which is not important. But in numerosity, remove the values of an attribute. Okay, so some of the parametric methods are regression, and non-parametric methods are very important: histogram, clustering, and sampling. That we will see in this particular part. What is histogram, what is clustering, and what is sampling. So first you come with histogram. So here histogram means you are concerned with values of an attribute. Okay, so values of an attribute. So first you go with dividing data into buckets and store the average for each bucket. Okay, so partitioning rules, one by equal width, other one is equal frequency. Equal width means, so width is same. Okay, so width, so size of the bucket. So here you see 0 to 10. 0 to 10 means how many values are there? 10. So here 10 to 20. How many values it will take? 10. So here 22 plus. So that will take also 10. So width is how many? 0 to 10 is 10. 10 to 20 is 10. 20 plus 2, some 30 is also 10. So width is of equal range. So whereas come for here, frequency. So frequency 0 to 14. So it is at value 3. Here it is at value 3. Here it is also value 3. So how many values you are considering? It doesn't matter. But how many values you have in each row? So all the rows are having under value 3. But here in equal width, you have to take like this. Go with the horizontal rows. So but in equal frequency, see the values. So this one minus to 14, it is having a frequency 3. Here also value 3. Here also value is 3. That is equal width means equal bucket range. Size of the bucket is 10. But value of the first bucket is 2, value of second bucket is 4, value of third bucket is 3. But you come for the frequency range. So here, no x parameter, go for y. So first bucket is having a frequency 3, second bucket also 3, third bucket is also 3. So that is histogram. So next you come for the next method. So see here, we are discussing all non-parametric methods. So first one is histogram, second one is clustering, third one is sampling. So we have one with this is histogram. Now you come with a clustering. Okay, so what the clustering will do? Partition the data into clusters, and one can store cluster representation only. So if it is effective if the data is clustered, but not if data is mirrored. So hierarchical clustering and be stored in multidimensional index tree. So different clustering algorithms are partitional, density-based, hierarchical, and grid that we will see in some of the machine learning concepts. So partitional and density-based, hierarchical, and grid. So it is one of the clustering. So now you come for the sampling. So very important part, sample. Take some samples and test your sample. So what the sample will tell? So sample will tell, so understand carefully. Take some, sorry, I'll write it here. So take some samples and test your sample. So sampling, okay, this is the very word what we have to consider it here. So the what we have taken, take some samples and test your sample. So sampling means obtaining a small sample to represent the whole data set. So simple random sampling may have poor performance in presence of skew. So where there are various sampling methods, example stratified. So that we will see in each and every slide now. Types of sampling. So very important concepts. Type of sampling. First one is simple random sampling. So simple random sampling, that we take it as S or S. Okay, so there is a equal probability of selecting any particular item. So next you go with a sampling without replacement. So that we take it as SWR. So sorry, so it will be without. So without you take it as WO. So S means sampling without WO and R for replacement. So similarly you go with sampling with replacement. So finally you go with the next one, stratified sampling. So these are the four types of sampling methods you have. Simple random sampling, what you will be doing, equal probability of selecting an item. So the what you have taken, so equal probability of selecting an item. So without replacement, once an object is selected, it is removed without replacement. Okay. So without replace means you are removing that particular item. Okay. If the object is selected, it will be removed, but it will not be placed. Okay. Sampling with replacement means selected object is not removed from the population. Sampling with replacement means it is not removed. That sample what you are going to test, that will not be removed. So stratified sampling means partition and draw the samples from each partition. So it is similar to, this one is random. Randomly you are taking a sample. But here it is stratified. That means you are partitioning the data and drawing the samples from each partition. So sampling with and without replacement. So here you will understand this is the raw data. Okay. So this one is without replacement. Simple random sample without replacement. Here you see first sample, second sample, third sample. But here with replacement you see white is taken out and you have replaced it with another green only. So this is without replacement. So you are not replacing anything. There is only one green, one white, one. Okay, so all the three are there, no replacement. But you come here, so only one green is there, but here you have replaced this white color with a green color, which is not there here. That means white color is replaced from and green color is placed here. Understand? So now you come for the stratified sampling. So stratified, that means you are taking upon a particular dimension. So these are some transactions are youth, some are middle age, some are youth. So according to age, if you are dividing according to age, so youth will start at 38 and youth will end at 391. So 38, 391. Similarly, middle age. So middle age you will start with 96 also, but they have started with 117 and it is ending, they are taken some samples of middle age. So you can take 387 also. Coming for senior, you have taken one sample. So stratify the sample what you have taken. So that is what you have taken upon an attribute, that we call it as stratified sampling. Next you come for the last one, compression. Okay, so what is the compression you have? So string compression, audio video compression, so that we will take it in this particular section. Okay, so string compression means there are extensive theories and well-tuned algorithms. So you compress a given string. So typically lossless, so that you will understand clearly when you go with a data mining concepts. Okay. So audio video compression means, so you can compress any file, audio file using video cutter, audio cutter, that you can compress. So here dimensionality and numerosity are considered as forms of data compression. So now you come for the next one, discretization. So that is up to here, it is up to reduction. So now you come for the next topic, discretization. So what you do, discretize means what type of values you have. So there are three types of values you have. So under pre-processing, now you are under discretization. So reduction part is finished. Now you come for the discretization. Three types of attributes. One is nominal, ordinal, numeric. So nominal means values from an unordered set, color, profession. Ordinal means military, academic rank. Numeric means integer or real number. So what you do in discretize, divide the range of continuous attribute into intervals. Keep in your mind, divide the range of continuous attribute into intervals. So interval labels can be used to replace actual values. Okay, so that is up to discretization. Now you come, which are the discretization techniques? First one is binning. So binning you have used in data cleaning to remove the noisy data. So it is used in binning, used in, sorry, not binning, it is used in smoothing the data. Smoothing the data means removing the noise. So binning by mean, binning by median. So that is the binning. Next, histogram. So the histogram we have already seen. Next we go with a clustering analysis. Next, decision tree and correlation, that you will be studying in detail there. So encoding categorical data. So how you encode the data? So integer encoding, if you take a red, integer encoding means any character can be taken as number. Red as 1, green as 2, blue as 3. So your encode means encrypt. So conversion from one form to another is called as encoding. So encoding, what you mean by encoding? So encoding means, so it is conversion from one form to another form, so that we take it as encoding. So for example, integer encoding means any character is been converted into number. Any character converted into number is called as a integer encoding, used when integer values have natural ordered relationship. So one hot encoding, so you see one hot encoding for red, green, blue. So all the principal diagonal elements will go with one. So these are the three types of encoding what you can go with. Okay. So next you come for handling class imbalance. So how you handle class imbalance? So that is, you have two concepts. One is oversampling, the other one is data undersampling. So oversampling means randomly duplicate examples. Over means examples data are there. You are creating the duplicate data. Duplicate the examples in minority class. Undersampling means, under means delete the samples. So here you are going to create the extra. Oversampling means create the extra samples. So similarly, undersampling means delete the samples. So combine oversampling and undersampling, you get the smooth. That is synthetic minority oversampling technique. So this is the next you will get when you go with a deep learning concepts, then you come across these words. So that is smart and all. Oversampling, first you understand oversampling, that means randomly duplicate examples. So already data is there, you are creating, duplicating. the data, so that is called as a oversampling. Also that will create more data. Undersampling means delete the examples in majority classes. So that next you come with a combination of these two. So we combine oversampling and undersampling, that is called as a SMOT. SMOT means synthetic minority oversampling technique. Okay, so now we have till now we have gone with pre-processing the numeric data. Okay, so now if you want to pre-processing the text data, what should be done? So these are the some of the methods. So first one is lower casing. If it is in capital letter, convert it into smaller letter. Next, removal of punctuation, stop words. Next, stemming, reduction the words by trimming. Next, you go with a lemmatization. Next, stop word removal. The other one is normalization. So normalization means, for example, the word good and good can be transferred to good. So that is normalization. So that is up to pre-processing for text data. So where these are applicable. So if you want to pre-process an image, what are all the methods you have to do? First, resize the image. Augment the image means once you resize, you will get the new image. So resized image is the augmented image. So resized image, we consider it as augmented image. Okay. So the third one, noise removal and transformation. Now, if you want to pre-process an image, what should be done? It should be resized, augmented, noise to be removed, and transforms. So these are the four methods what you take. Next, you go with which are the research directions. So some of the research directions in image processing are instance reduction, noise removal, feature selection. So combination of data preprocessing to get the optimum result, and use of supervised and unsupervised for real-time processing. Okay, so no free lunch theorem. No one model works best for all situations. We have four situations here: instance reduction, missing value imputation, noise removal, and future. If you want, one algorithm will not work for all the four. These are the some of the research directions of image preprocessing. Understood? So this is up to the data pre-processing techniques that we have discussed, data reduction and discretization methods. Okay, this is up to the data pre-processing techniques. So I hope you all got understood this particular concepts. So listen carefully, understand the basics concepts. Okay, so I will be ending this particular session here. So hope you people understand. Subscribe for the channel for getting more videos. Thank you, one and all.